Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. In this video we will discuss CD4017. It is CMOS IC decade counter, how we can use it in different ways and how you can simulate in the software. Then you can design any circuit practically. What is CD4017? It is a decade counter. It have a clock in. You can give a pulse here, clock pulse here, any pulse you want to count it, you want to set its amplitude and volts. Pulse voltage we can say 5 volt. Frequency we will use, for example, 10 Hertz. Okay, now we have enable pin, we have master reset, so we have to ground it, enable and reset, connect ground. Actually this decade counter counts the binary pulses which are coming to pin number 14, and it have 10 outputs from Q0. Q denotes to outputs, Q0 to Q10, these are outputs, and this is carry output. Now it will count the pulses, and we can select a LED, or we can drive any other circuit. For example, to display on LED we have 5 volt output. It have 0 volt or 5 volt output. If low, it will give 0. If it is high, it will give 5 volt. If we want to connect LED, so output voltage that are 5 volt minus LED voltage 1.8 volt divided by 15 milliampere 0.015, so we will find 213 ohm, and physically we can find 220 ohm. Or if we want to design it at 10 milliampere current for more safety, 5 minus 1.8 volt LED voltage divided by 0.01, we can use 330 ohm resistor. It is 320, we can use 330 ohm. We can select 220 or 330, anyone. For example, I want to select 330 ohm resistor, P330R. We can select 330 ohm resistor. We will connect it here. We can place animated LED, we can use it because we have to show on the screen, and then we will design it practically. So we can select any colored LED. So here is yellow. Okay, yellow is good. Rotate it, rotate anti-clockwise. Okay, this here, and we will place ground to the cathode of LED. We can simulate it. We can see the outputs are moving, but we don't have any LED there, so one LED is blinking after 10 cycles. Now we can connect the other LEDs in the outputs. Now I connected LEDs 13, 15 ground. Carry output we will use in the next stage. Now after each 10 pulses it will start from 0, from the first LED. So it is working in this way. Now we can use the two sets of same configuration. Here I connected two sets, the similar sets. I applied clock pulse to pin number 14, and these two pins are grounded, and here I connected clock pulse to the carry of first IC, and the other two pins are grounded. And if you want to connect another stage, then we will use this carry to the next counter. So it is decade counter. Now we can see the first set, when it will reach to end, it will give one carry pulse to the next stage. Now this counter is slow. We can connect more sets, next outputs. Every carry will drive to the next circuit, but the frequency will divide it by 10. After each 5 cycles here in the first stage, the next pulse will go high, and then next 5 cycles it will remain low. Now I connected 4 decades, 4 sets in the series, the same configuration. The first, it will driven from any clock source, any binary input, and then the pin number 12, that is carry output, I will connect to the next stage input. Pin 14 is input. Now we can 12 to pin number 14, 12 to pin number 14. So I connected all sets in the series. Now I will simulate it. We can see now the second stage is counting pulses. The first stage, it is counting at 10 Hertz. Then the frequency is pulses are moving to the next stage. When it will complete its cycle from 1 to 10, it will shuffle one pulse to the next circuit. When it will complete its cycle, so frequency here will divide it by 10 at each stage. Let's increase the frequency and then we can see. Now I will connect 50 Hertz for example. In the first stage we can see it is counting very fast. It is dividing by 10. Now this stage will receive 5 Hertz and it will receive 0.5 Hertz because every stage will divide by 10. This stage is very fast, the first stage very fast because it is driven at 50 Hertz. The second stage is slow. It will divided by 10, it will receive 5 Hertz clock cycle, and then it will receive 0.5 Hertz cycle. Every cycle will divide by 10. We can configure these LEDs in any circle shape or any, so it is giving a ring motion. We have to configure these pin numbers here. It is output number 1. Output number 1 is at pin number 3, that is defined as Q0. In next video we will make it practically. I hope so this video is informative. If it is informative, hit the like button. If you have any question, kindly let me know in the comment box. I am using Proteus 8 Professional, 8.2 Professional. You can use for designing, simulating. It's a very useful circuit designing software. Thanks for watching. Assalamu alaikum warahmatullahi wabarakatuh.